Hi, it's me again. Happy to see you too. Hey, guess what? I've got some more to look at. Lots of things I want to review today. It's Saturday, and I've got Sunday, Monday, Tuesday before I got a big gnarly midterm coming up. I'm Doug. I'm a physics student at the University of Utah, old man physics student. And you know what? I'm kind of learning stuff here as I go, and I'm hoping I'll help you out too. But here's what I'm going to do. I'm going to look at today. Well, it's summer and it's really hot outside, and when it's hot outside, we start the barbecue. And my barbecue, I don't know about yours, mine runs on propane. So I'm going to look at the combustion of propane, but I'm going to make this kind of gnarly so that I can. I said gnarly already. I'm going to look at a few things. I'm going to look at the combustion of propane. I'm also going to look at diagramming propane, and balancing equations will kind of factor into this whole thing too. Okay, what do we know about burning? We know the burning is when you take something like this propane molecule here. Okay, you know, I'm getting really nervous saying this, but I think there's the slightest chance I could have gotten that formula wrong. I just want to check before I start the whole thing. I'm gonna start over. No, no, I'm not. Okay, you know what? Propane, just doing a quick Google search here. Propane is propane's on Wikipedia. I wish I had my own Wikipedia page. Ah, yeah, there it is. Okay, and it looks like I got the formula right. Yep, C3H8. Okay, my memory's not as bad as I thought. All right, so when I burn things, what I'm going to do is I'm going to take whatever this molecule is, and I'm going to add it to O2, and that O2 is going to give us CO2 and H2O as the end results. That's burning stuff. Okay, so maybe I should write that down here, okay, as a whole equation. So you kind of see where this is going if you've done any of this before. C3H8, right? 3 carbons and 8 hydrogens. And when I mix those with oxygen, I'm going to get carbon dioxide, and I'm going to get some water. Okay. Now here's the thing. Well, here I'm going to start a way here. That's all well and good, but I have a sneaking suspicion that this isn't a fully balanced equation, and I'm just doing this on the fly, so be patient. Here we go. I'm going to count things up. This is how I do it anyway. I say, okay, wait, new color, back up. Okay, so C3. Actually, let me write down my molecules. I've got C, I've got H, and O. Okay, carbon, hydrogen, and oxygen. I look over on this side, carbon, hydrogen, and oxygen. That's good, no surprises. You don't want things showing up on one side. What am I doing? Showing up on one side that weren't on the other. Like, you know, if you had a sulfur come out on the other side, you know something was definitely wrong, because unless you're magic, I guess, but magic isn't real, so guess what? It can't be magic. You have to solve it. Here we go. 3 carbons. That looks good over here. 3 carbons, okay. And over here I've got 2 carbons. That's going to be a problem, right? Over here I've got 8 hydrogens, and that's it. So 8 hydrogens, okay. And I look over here and I've got only 2 hydrogens. That's also a bit of an issue, right? Yeah, yep, it is. Okay. So let's look at the next one. Oxygen, that's got 2. And over here, I've got a lot more oxygen. Actually, I've got 2 here, and well, not a lot more, I guess. I've got 3, okay? Let's check and make sure that's right. 3, 8, 2. I've got 2. I like to write them in the same order, right, so that they're easier to check. 2 carbons, 2 hydrogens, and 3 oxygens. Good. So what I need to do is figure out a way to make those 2 sides balanced so that I can actually do my calculation for the energy of the reaction, right? Or the amount of heat for a barbecue. So looking at this, I've got 3 and 2. 3 and 2. Do I want to do that one first? Nah, maybe I want to do the easy one first. 3, 8 and 2, 2 and 3. Let's. There's probably not going to be a super easy way for me to approach this. It's kind of hard to jumble all your thoughts, right? So let's see. I'm going to try and fix the hydrogen first. Let's do that. Okay. Why? I wanted a new color, I said. Okay. So that's going to be 4 H2Os. Does that make sense? Because I want to go 4 times 2 is 8, and that would get me to H here. Of course, there will be other consequences, right? Okay. So I'm going to say this now is 4 times 2 is 8. But now I've got 4 times 4, 1 is 4, plus 2 is 6. So now I've got 6 oxygens over here. That's not too bad, right? So 2 to, okay, now I need to work out the carbons. I'm leaving the simple one alone because, you know, if I'm lucky, I'll get to just work out the oxygen in the last step to an even number, and I can do that with the O2. So, let's see, 2, 3, 2, 3, 2, 3. Wow, okay. It'd be really nice if I could just get 3 of these, right? Then I'd have 3 carbons. So let's do that. Let's put it in a new color though. So I'm going to go 3 carbons here, right? But that changes everything. So, oh, you know, I just realized I made a really dumb mistake. Okay, let's not call it a dumb mistake, right? Don't want to be a bad teacher. Okay, here we go. I meant to say 1 carbon over here. So actually we were closer than I thought. Okay, so going back to this, I still need 3 of these, right? 3 over here. So I want 3 over here. That's going to be 3 carbons, but now I've got 3 times 2 is 6, usually. 6, okay, plus 4 times 1 is 4. So now I've got 10. Hey, this one worked out pretty easily. So that's 10 oxygen atoms. And over here, I've got 2. Well, that's an easy fix, right? Because I can just now say, let's make that 5 O2s, and that'll give me 10. Okay. So now I've got 3, 8, 10, 3, 8, 10 over here, right? And I've got a balanced equation from which I will be able to work. Okay. That's my first step. Okay. I'm going to get rid of these because I don't need them anymore, and they just kind of cluttered things up. All right. Now, with my balanced and colorful equation, which I suppose I could just, you know, turn, no, that didn't work like I expected it to. All right, anyway, with this balanced equation, now I can start doing things like calculating energy. And I realized that, man, I'm really getting into this far and ugly, and maybe this wasn't such a great idea. We'll do it anyway. Okay, so how many bonds are being broken here? This is pretty tricky, right? Because let's just take a look at what this this guy right here, the propane, looks like. I've got 3 C's. Maybe I'll just draw the C's first, right? C, and a C over here maybe. Okay. And I'm not really worried about the shapes too much at this point. Yeah, where they're going to be relative to each other. Just want to get the bonding right. Okay. Boy, do I really want to do that? You know, I'm going to shortcut this. Okay. You could diagram them out. Maybe I'll do a diagramming video later, but that'll drag this out, make it really long and more boring. So I'm going to go carbon, carbon, carbon. I'm taking this straight from Wikipedia. Okay, and I'm going to have a hydrogen over here. And the reason I'm doing this is I just want to get a notion of where all the bonds are and how many I'm going to have to break up. Because if I know that, then I can you know, assign an energy value to each one of them. And once I have those energies for each bond being broken or reconnected, okay, then I'll be able to tally them in a single column and come out with a nice little number, and that'll be the energy of the reaction. So let's say, well, let's just start counting this up. Okay, I've got, well, the first bit of information you're going to need is how much does it cost, or how much energy is released on break, or not released, excuse me, how much energy do I have to put in to break one of these bonds right here? Okay, I'm talking about the carbon to hydrogen bond in propane. Okay, so as it turns out, that is going to be 413 kilojoules per mole. Okay, 413 kilojoules per mole. Now I get to do another lovely counting exercise, and these are easy to screw up, so you got to be careful. How many bonds are there? They're going to be 1, 2, 3, 4. Oh, don't count that one. 1, 2, 3, 4, 5, 6, 7, 8. I'm counting 8 of them. Should we double check that, make sure? Okay. 1, 2, 3, 4, 5, 6, 7, 8. Well, I didn't really need to count those, did I? Because I can see that there are 8 of them in the formula. So that's 8 carbon to hydrogen bonds that I need to break, and that is going to cost me 413 kilojoules apiece. Hang on a sec. 413 kilojoules. Actually, let's do it this way. 8 times 413 kilojoules. Okay? 8 times 413 kilojoules. That's my first step. Okay. Next step. Okay. Next step is I need a snack. Okay. Next step is I've got all these. What do I need? I need to. Oh yeah, the carbons. So let's look at the carbons. I've got carbon is going to be 1, 2 carbon bonds. Is that it? Oh, wait a minute. 1, 2. Yeah, the carbon-carbon bonds looks like there's just 2 of them right between the carbons. Okay, so I've got 2 carbon-carbon bonds, and these values you could just look up in the table. I don't know why I just wrote CH there though. Multitasking, biggest human fallacy. We cannot do it. Okay, so C to C, all right? And carbon to carbon bond, oh, you know, I thought I had that handy. I need to look that up in my handy dandy table, which I don't have here. Give me just a minute. You got the book? Got to pause that. All right, took me a minute, but I found it. Okay, so I'm looking for the 2 of these carbon-carbon bonds, and that is going to have a bond energy of 347. What is going on with my pen? 347 kilojoules. These are all per mole, but I don't want to write it all out. And I've got 2 of those, right? Maybe that would be easier to see if I did this, right? Okay. Now, carbon to carbon, okay. So I've got 2 of those. I got 3 of those. That covers the propane, right? I'm not going to write that anymore. Lag issues. I need a more powerful computer. Somebody hook me up with that. That'd be great. Okay. So next is going to be, I've got these, right? So I've got O2 bonds I need to break up. And those are a double bond. Okay. Is that right? Let me think about that. You know, I probably should have prepped with a, yeah, that's going to be a double bond. Okay. So the oxygen to oxygen in the O2 is going to be 5 of those, right, that I'm going to break up. Is that right? Oh, goodness. Yes, I'm getting a little sluggish. Okay, so yeah, I'm going to break up 5 of those, and they're going to come at 495 apiece. Okay, so 495, 5 times 495 kilojoules per mole. Okay, and that's good. So that is our first half. Okay, that's the left side of the equation over here. Now the second half, this is bonds broken, right? And now we want to do formed bonds. Okay. Now the forming. Okay. So when I form a CO2, CO2 is kind of a tricky one, I think. Let me think about that because there's always a little asterisk. Okay. When I have a carbon in CO2, that's going to be. It's going to be 799, okay? So 799, let's just write that over here. Okay, so that's C to O. Okay, and this is for CO2. Is going to be equal to 799. Okay, 799 kilojoules. Okay, and the next spot is going to, oh, actually, let's not forget, that's going to happen 3 times, right? Okay, so that's good. And what else do we have? 4 H2Os, right? So let's do that. I'm going to have 4 O to H bonds, right? So O, yeah, I probably should, let's change colors so I don't get it all confusing. In fact, I should have done that for this one because now you're going to look at them the same way, right? Okay, it's H2O. So I've got blah, blah, blah. Oh, I forgot to put a 5 over here, sorry. 4 H2Os. Or, nah, stop that. 3 of those. 4 of these. Okay, so I'm going to have O to H bonds that I need to combine to make the water, right? And, well, let me think about this for a minute. That's going to be, well, let's just draw it out because I'm having trouble thinking out loud. I'm going to have H, H, O like this, right? Okay, so there's 1, 2 in each one. I have 4 of those, so I'm going to have 4 times, is that right? 4 times 2 is 8 of those? Yes, okay. So I've got 4 of these water molecules that I'm creating, but each of those is going to have 2 HO bonds. There, that's better. Okay, so I'm going to take this, I'm going to say OH is 4 for the water molecules, right? Times 2, because there are 2 OH bonds in each one. Okay, and if you're watching this and you're pro at it and you're ready to just crucify me in the comments, that's cool. Just show me where I messed up and I'll be happy to annotate it and fix it later. So, all right, 4 times 2 is 8, right? Mostly, for most values of 4 and 2. And that's going to be 467 apiece, right? So 467 kilojoules apiece times 8. This video is getting very long already. So now I'm going to say 8 times 467. Okay, now the trick is I'm going to take the bonds broken and the bonds formed, and I'm going to add them all up, and that's going to give me the energy for the reaction. So I need my megalithic calculator here to do it. Leftovers from the last one. I've got 413 kilojoules. Okay. And that's energy going in, so that's going to be positive, right? Well, actually, I don't want to think about it like Bornhaber in this case. I'm just going to subtract bonds broken from bonds formed. Oh, Windows, I hate you. Ugh. Die, die, die. Okay. Nice wallpaper, though, right? Okay, so 413. Right? Up here, that's where I was. Sorry for the window rearrangement crap. I take 8 of those for 3304. Okay, the next step is 347, and that's going to be twice. Okay, and then 495. Okay, and then 5 times. Okay, and I'm going to add those all up. Plus, plus. Okay, that comes out to 600 or 6473 kilojoules per mole in breaking bonds. That's energy that goes into the system. Okay, these, as I was starting to say earlier and kind of got unsure of myself, these are going to be the bonds formed, right? Bonds formed. And I have a visitor. Hi, I'm recording. But I can't get mad because she just brought me cookies and milk. Say hi to everybody.
Hi.
Okay. Thank you. Yeah, it's live. You're on. You're famous now. Okay. Anyway, so here's what I'm going to do. I've got 6473. That's nice. Okay. Anyway. Oh yeah, I've got to subtract these over here. All right, because these are going to kick off energy, so they're going to be negative. So 799. I'm going to multiply that by 3. Okay. I'm starting to feel a little unsure about this whole thing. Okay, I've got 467 times 8. That's going to be negative also, right? I add those up together. Oh, that makes me really, really nervous because, you know, yeah. Hang on, please. All right, I just found a mistake that's going to cost us a little bit. I said there were 3 right here. Well, that's not strictly correct because you remember how I did this down here? These CO2s, while we had to use a different value for the heat here, really that should have been 3 times, let's do that again. That should have been 3 times 2 because there are going to be 2 carbon-hydrogen bonds for the carbon dioxide, but there are 3 moles of it that we're dealing with here. So that's really going to be 3 times 2 times 3 times, which is 6, of course, is going to be 6 times 799. So let's run that again. I'm confident in this left side though, so we're going to keep that one. And let's come back up here. 2, enter 3 times 6. I don't know why I did that. 799. Okay, is this one, so I'm going to multiply those out. And then I've got 8 of these OH bonds to form. And that's going to be 467 kilojoules per mole apiece times, yeah, that's good, okay. And I add those together, all right? And this part, this side over here is going to be 8530 kilojoules per mole, right? All right, now, it's going to be negative, right? Because when we break the bonds, that takes energy. We have to pump energy in to make things fly apart. But when they fall back down again, they go, ha, and the energy goes out. And that's the reaction. So I'll show that here with a negative sign. And what I'm going to do, or you can leave it positive and subtract when I finish, that puts me at this. And so whenever I'm out on the barbecue grill and I start it up, oxygen in the atmosphere combines with propane from the tank to give us carbon dioxide and water. And when it does, it creates, or releases, I should say, 2,057 kilojoules per mole of energy. And that's that. You did it. It only took 20 minutes. Better get faster for the test, right? All right, talk to you later. Bye.